Okay, this is a circuit for the servo and DC motor control over Bluetooth. There's a DC motor, servo motor, Bluetooth module so that we can connect to phones or tablets, battery pack which is used to power the motors, an L293D motor driver IC, and the connections necessary to connect this circuit to the PSOC4 board. For example, P00, P01, P04, P10, ground and VDD, and these can all be seen here. Here's VDD and ground. There's also a VDD and ground down here. P04, P00, P01, P10. Look at the price. Also can be bought in Ireland from other distributors. Back to the diagram. One thing to note, the L293D, the notch is here, and this is pin 1 all the way down to pin 8, up to pin 9, back to pin 16. There's a little truth table here indicating what numbers should be sent out of P01 and P00 to control the direction of the DC motor. Pulse widths coming out in P10 control the position of the servo motor. If you notice the Bluetooth module, there's 3 connections. Ground goes to ground, and all the grounds are actually connected together here, you can see. The TX of the Bluetooth module is connected into P04 on the PSOC board, and the supply is connected to the VDD, which is also connected into VDD of the PSOC4 board. If you look at the DC motor, you'll see it's connected to pins 3 and pin 6. The battery pack, ground to ground, and the 6 volts goes to pin 8. And you'll notice there's also a wire coming out from pin 8, which is also the supply voltage for your servo. The ground of the servo goes to ground, and the signal goes to P10. I've put a little capacitor across the motor as recommended by the L293D data sheet. So basically, when you send commands from your phone, it's picked up by the Bluetooth module, fed to the PSOC board, which decides what to do with the DC motor and the servo motor. Obviously this depends on what you press on your tablet. This package here was used to draw up the diagram, and as you can see, it's very good for documentation, and it can be downloaded from fritzing.org. So if we go back to diagram, again, be careful that you place this chip across the ridge in the middle, pin 1, pin down to pin 8, over to pin 9, up to pin 16. And this is a 6 volt DC motor. And back to this table once more. If the PSOC board writes out 00 on these 2 lines, this motor is off. If it writes out 1 and a 0, this motor goes forward. If it writes out 0 and 1, this motor goes in reverse. The servo motor needs pulses 50 times a second or every 20 milliseconds, and the duration of these pulses indicate the position of the motor. For example, the one I'm using is approximately around 900 microseconds to 2 milliseconds, takes it the full 180 degrees. So that's basically the hardware, and we'll shortly have a look at how we actually program the PSOC board to do the control.